In part 2 of this activity, we use a Java model to explore future concentrations of CFCs for different emission scenarios. First, we'll click on this link here. And depending on your browser option, this looks like it's Mozilla. The file will come down and you can open it up. The file is not it's a standalone file, it's not part of a browser. Okay, and so this is a picture of the CFC concentrations in the atmosphere up to the year 2000. So this is 1998. Down here there's a tiny times 100. And this is the concentration level on the y-axis over here in parts per trillion. Okay, so if I run the model right now, this is data that we looked at earlier. And if I run the model, right now the model predicts a very low level of CFC concentration, much lower than the data suggests. So there are two things that I can do to control this. One is I can control the emissions in parts per trillion per year. That's how much CFCs are going into the atmosphere each year. So I can control that with a slider. Or I can just type the number in here. Let me put 20, for example. And I have to make sure that I hit enter. Notice it changes from bright yellow to the lighter yellow after I've entered it in. And now run that. And so just changing that emissions of CFCs into the atmosphere has improved the fit between the model, in this case the green line, and the observations, the black dots, quite a bit. Okay, the initial value of CFCs in 1980 of 296, I don't want to play with that because that's pretty well set. Here I set this to match. And the growth rate, this could be an increase or decrease in this emission. So this growth rate is the emission growth rate. You don't get to play with the atmospheric lifetime in here because the atmospheric lifetime of CFC12 is fixed at 100 years. So this makes it pretty easy to simulate different things. So in the activity, you will be answering these questions. Okay. So in this case, change the 1980 emissions and possibly the initial concentration. I don't think you need to do that to get the best fit between the model and observations for the first 5 years. Okay. And then in the next question, so this is what that looks like. In the next question, do the same thing, get a good emission fit for 1985 to 1989. 85 to 89. Notice in this case, we changed the initial 1980 concentration. We weren't worried about getting a good fit between these data. We just wanted to make sure that all of these data points fit pretty well. And so you'll get a different emission for that. And then answer some questions. Let me go back to the model and do this one here, just kind of show you. So I'm going to reset, and I'm going to try maybe a concentration of 23.6, run it, and notice that the line here is fairly parallel to the 1985, 86, 87 data points, and now I can just lower this value down. Maybe I'll go down to 280 or something like that, till the line matches pretty well. Okay, still a little high there. Okay, and so maybe I want to change this to 275 and run that again. Okay, and notice that this thing changes, so I have to make sure I change that. But that gave a pretty good fit. So 23.6, that's just a random number I chose. Probably you get a pretty good fit somewhere between, anywhere between 23 and 25 is my guess. But I should reproduce this, reset this, and I'll go 24 and 275 and run that. I'm still a little high on that, and so maybe I should go to, I'll reset it and go to 270 and 24 and run that. Yeah, that gives a pretty good fit. Although it fits really well for 85, 86, 87, but I'm a little bit below 88, 89, so maybe I do want to crank this up a little bit and get that. So let me try 25 and 265. Yeah, and that looked like it'd probably be a good fit, and so I'd want to refresh that. Okay, so this is looking at the idea that we can fit all the data by saying that the emissions increased at a certain percentage. All the data between 1980 and 1990. Okay, notice how this curves up a little bit. So play around with not only the emission source that you start out with in 1980, and that would be the same value that you got a good fit with up here in question 5. Okay. But then also get an increase in the emission source, R, to get that to make a good fit. Okay. Again, in our model simulation, you can control the growth rate, percent increase of the emissions by this number here. Then this value would be about right. So let me just try to get a good fit for those first 3 years. Let me say that I'm going to put an increase of 2% per year. See what happens there. Oh, that's too much. Okay, so less than 2% to fit. Again, I'm just looking at fitting these the first 10 years here of the data. I'm not trying to get this to curve over right yet. Okay, answer the questions, and now we're going to start at and go into the future. Okay, so another option that we have on our modeling environment is this little checkbox down here. Oh, here it is, up there, CFC 12. So this allows us to go into the future. Oh, I should reset, hit this checkbox, and maybe change this to 21 or something like that. 21 parts per trillion per year, and go on to the future. That's way out in the future. And then the last one, CFC number 3 here, allows us to just try and get a good fit of this data here. Okay, and we're starting in 1990. Okay, with an initial concentration of 475, 0% growth rate. So 1990. Let me run that. Oh, okay, the green does a pretty good fit. So let me refresh that. And again, I have to go to this 3. But 475 and yeah. So this emission that is default in here looks pretty good. It fits the first 2 points. And now let's get a negative growth rate. Let me say 13 and see what that does. Well, that's decreasing the emissions, or effectively decreasing the number of CFC factories too rapidly to match the data. What we want to do is use the model to see what did happen. And then that will allow us to project into the future too. So I'll let you play around with getting a good fit. Again, this is the CFC number 3. Reset, and it goes to the first one that we looked at, trying to get a good fit between 1980 and 1990. And then number 2 allows us to, CFC number 2, this little checkbox up here, allows us to go into the future. But you're going to have to adjust the future emissions to what you used for 1980 to 1990 best fit to see where it would go in the future. Hopefully this will give you a hint, a good solid hint to get through the rest of the activity. Good luck.